Hello everyone. Today we are going to just learn about the topic relation and function, the very first topic of class 12 standard. This topic is the combination of two parts, relation and function, and we have to learn them isolately first. So very first we are going to touch with the topic that is relation. This topic is familiar for us in the class 11 standard. There we have learned about the definition of relation, how we can define the relation, its perspective of writing the relations, find the domain and range, etc. Just for a glance, I am just telling you simple thing. Relation is a rule which can associate two sets, the element of first set to another set, two numbers, two persons, and that relation can be a different kind of things, different kind of definition. These elements can be written in a particular format that define the ordered pair, and basis on that we people are defining domain and range. That portion we have learned in the 11th standard. Now we are switching ourselves with the 12th standard. In 12th standard, simply relations, we have to touch the type of relations. So we are bothering about the type of relations. So very first we are going through with that, and that is type of relation in 12th standard. Normally in our syllabi we have three type of relation. First is reflexive, second is symmetric, and third is transitive. One by one we have to go through with them. One by one we have to learn them. What is reflexive, what is symmetric, what is transitive. So relations, we have three type of relations. Among them, very first we are going to touch the very first topic, that is reflexive relation. That means to say, if we are relate the element of any one set to another set, then what kind of relativity defined as reflexivity, that we have to learn about. So reflexive relation is what, guys? Any relation is said to be reflexive if it relate itself to itself. The important is itself to itself. So reflexive relation is what? A relation R is said to be reflexive if it relate itself to itself. In this definition, the very important thing is what? It relate in itself to itself. Any kind of relativity which define that, which relate itself to itself, known as reflexive relation. For example, if a person relate with itself, that reflexivity. If a line is relate with itself, that is reflexivity. Any kind of relation which shows this thing, it relates itself to itself. In definition, I can say a relation R is reflexive if A relate A. Any relation R is reflexive if it's A relate A. I am saying the same thing what I told you people. It relate itself to itself means A relate with A. In other words, I can say AA belongs to R. So that is the definition of reflexive relation. In order to prove any kind of relation, we people has to go through with that. We have to ensure that every element of that set is relate itself to itself. That is the definition of reflexivity. Exemplary, so if I am quoting some examples for clarifying this reflexivity, say guys, here is reflexivity example, say set A. The first kind of example is set A, elements are 1, 2, 3. And I am quoting some example, say relation R1 is given in term of ordered pair 1, 1, 2, 2, 3, 3, etc. Now is our major portion is what? We have to understand whether this relation is a reflexive relation or not. So what we have to be ensured? In the given set, we have three elements. We have to ensure every element of that set having the relativity with itself. Apart from that, what we have in the relation, that doesn't mean for us. The important part is we have to concern every element should relate itself to itself. And this relation R1, we are having that. So this relation we treat as a reflexive relation. Another example I'm giving you people, say R2 is there, it is 1 1 2 2 3 3 1 2 2 3 etc. And our job is to search out whether it is a reflexive or not. So what we can do, we have to just bother about the thing, only one thing, what? Every element should relate to itself. That means 1 1 2 2 3 3 should be there, except that what the element rest is there, that doesn't matter for us. In case of reflexivity, we should bother it. These three elements should be there if element is these three. So that is again an example of what, guys? Reflexive relation. Say another example, I am quoting that it is R3. An example is 1 1 2 2 1 2. That is another relation R3, and our job is to find out whether it is reflexive or not. So what do we do? Now we have to check these three elements 1 2 3 having the relation with itself or not. 1 1 is there, 2 2 is there, but 3 3 is missing. That is not a part of this relation 3, and due to that this portion R3 will not treat as a reflexive relation. 3 3 is not belongs to 3 3 is not belongs to what? R3. This implies R3 is not reflexive. R3 reflexive nahi hai. So that is the definition, exemplary. So in just precisely I can say, in case of numerical methodology, in case of roster form of any set, we have to ensure every element of that set should relate to itself. Another example for the reflexivity, we should go with that. And the example is general algebraically. Say, I'm saying here, a relation R is given by ordered pair L1